roles in informing how certainly the various people in Kruger try to make Kruger thrive. We're going to have a little bit of a session later in about half an hour. But we're going to start off this morning with a presentation that actually illustrates how science and managers actually work together. I'm actually going to ask Stephen Whitfield, because he started all this, you know. He started forcing me and Tim to work together. So I'm going to ask Stephen to just come and give us a quick 1-minute context of why Tim is going to talk to you this morning, to help put in context that, yes, scientists and managers actually can work together, even if it is Stephen.
Thank you very much. I got caught with my pants around my ankles with this. But just where this project initiated, I think with the success of dehorning, when we were meeting as protected area managers, there was a discussion that we should do an analysis, or a little bit of it, like the scientists would call it, a deep dive into dehorning, why it worked and what worked well. And then in that forum, there was a sentiment that we shouldn't just focus on dehorning. We should be focusing on everything that we've done from when rhino poaching became a challenge. Because it's important to understand that dehorning is not the silver bullet, and that there was a lot that preluded dehorning. So we got together then again, and we decided what were the interventions that have taken place, and how should we be analyzing these different interventions. And our end objective was to try and take that wealth of experience that's been gained by doing as many wrong things as right things over 15 years in trying to combat rhino poaching, and trying to take that wealth of knowledge and put it together in a meaningful way for managers to be able to look at it and delve into it and see what works at what scale, what works together, what doesn't work together. And that's when I met Tim, and Tim came in sort of on the scientific side of it. I grew up as a ranger's son who said to me, scientists are the crazy people that do a doctorate on why cockroaches have 6 legs. And if you need a park manager, go and get a mechanic who loves the bush. But I'm really glad to say that I think in our generation, scientists and managers have really gravitated towards each other. And science is mostly driven towards enabling management decisions. So we don't sit at the opposite ends of the table anymore, which I'm very glad to say. And it was a real pleasure working with Tim, because he was the one scientist sitting in amongst a bunch of managers. And I think we made him mad, because we kept telling him, this is management, this is management, this is management. This has got to go back to a manager having a manual in the cubbyhole of his vehicle, and he can access that, and that must be able to help him make better decisions. I think the job that everybody had in doing this was incredibly difficult, and I use the analogy of it's like taking a smoothie and trying to undo all the scrambling that you've done and turn it back into avos and tomatoes and carrots and cucumbers, because we never went into these interventions thinking we were going to have to analyze them. So it was a very difficult job, and I think Tim had a very difficult job, but it was amazing the journey that we've walked with Tim. So I think if that can just give you a little bit of an intro into how we got to where we are.
Thank you very much, Stephen. And Tim, you now have got some serious standard to live up to. Take us away, please.
I'll just say that I asked Stephen to do that about half an hour ago. So that was a very good summary of the project with very short notice. I've loved working with Stephen. I asked Stephen to speak because it was actually Stephen, together with a lady called Sharon. I don't know if I can have my slides up, then I can navigate to Sharon. Sharon on your top right there. She's the director of the Greater Kruger Environmental Protection Foundation. She works with the private reserves alongside Kruger. as well as Kruger itself, and her mandate has been to create this space where managers of these various entities can get together and strategize together. And I think Project FIRE, this project on rhino poaching, Project 2 I'll talk about, was birthed out of managers sitting together thinking critically about what they had done to date in terms of tackling rhino poaching, and this desire to really strategically evaluate what worked and what didn't work as expected. So it was an absolute privilege to join that team at halfway through the project. As a statistician, my background is maths and stats, and to sit down with the managers and look at these data. And I think Stephen's analogy is perfect. It's a very messy system. These interventions were not randomly applied, so ideally you would have a randomized control trial like they do with things like the COVID vaccine. But it isn't possible to randomize interventions in a space like this, and it's ethically questionable. But anyway, I just wanted to acknowledge Sharon, and just say that I'm really standing on the shoulders of giants. Stephen, Sharon, other mentors I've had. That's Stephen on the bottom right. He loves flying. And Sam's been a mentor to me from the scientific side over the last 2 years. Professor E.J. Milner-Gulland, some of you might know her. She supervised my PhD in the UK and has been an incredible mentor. She was the person introducing me to people at conferences. Professor Altweg, he's at the University of Cape Town. I think the wildlife management community, conservation community may not be aware of his work, and I just wanted to give a plug for him. If you Google the Center for Statistics in Ecology and the Environment and Conservation, it's SEEC, S-E-E-C, a phenomenal group of researchers that works on applying appropriate statistical methods to understanding ecological data. But I don't want to stop here, because I'm so happy to see today some of my undergrad lecturers, Brad Ripley, Susie Vetter, and Dan. Shout out to Dan. You won the game because I ended up in your field, mostly. Large mammal ecology and conservation. Dan introduced me to that field as an undergraduate. He linked me to the Wild Crew, the Oxford Lion Project in Zimbabwe. I ended up doing my honors project with them. So yeah, Dan's just been a really fun guy to be around and a really good mentor to me, and I wanted to thank him for that. And he's written probably 50 reference letters for me. So thanks, Dan. And then just to also acknowledge that previous speakers today, Annette, Haley, the two of you I've sat down with personally. You're a bit further ahead than me in terms of your careers and experience, and I've learned a lot from our discussions, particularly with Annette around rhino poaching in this space. She didn't really touch on it, but she did some groundbreaking work on the social economy of rhino poaching in this landscape. I think the title of the paper is exactly that, if I'm not mistaken. But please do check out that paper. She had all sorts of interesting interviews with criminal syndicates and ex-poachers and all sorts, but shining a completely different light on the problem, and one that helped me think as a statistician and as an ecologist more clearly about these kinds of problems. So I really do acknowledge and thank my colleagues and friends. And the last person, and I'm really abusing my half-an-hour slot here, I'd like to thank my wife, Danica. She might be watching online. I think she is. She is my graph filter. So I've got lots of graphs in this presentation, and they get a bit too complicated. And I want to make sure they're understandable to the layperson, and so I'm always calling her to my computer and saying, tell me what this graph is saying, without showing her the figure legend. And if she can translate it, then I know it's ready to go. The first project I'll be talking about today is drivers and facilitators of elephant poaching. So this was a bit of my postdoc work. It was funded by the Program for Monitoring the Illegal Killing of Elephants under CITES. And this program relies heavily on ranger-collected data. And I just wanted to emphasize that. I believe there's some rangers in the room. That the data for this project were completely collected by rangers and part of a global database across, I think it's 64 countries, almost 90 sites, where rangers collect data on poached elephant carcasses. As you can see, the photo on the right is one I took during my field work in Zimbabwe during my PhD. I think he's just posing by the very old elephant carcass for me. Yeah, so I just want to acknowledge the rangers. These are the sites. So we use poaching data from 64 different sites over a almost 20-year period. And during that time, over 10,000 records of illegally killed elephants were made. And there's this very simplified metric, because you can imagine there's differing numbers of elephants, differing intensities of ranger patrols at these sites. So if you just looked at the raw number of elephants poached, it would be strongly biased by those factors. Initially, they wanted really good data on patrol effort to weight these numbers by, but that wasn't forthcoming. And someone developed a nifty little index. Both the numerator and the denominator are affected by patrol effort. So in some sense, they cancel each other out. So this index of pike, roughly if it's above 0.5, it indicates that that's probably linked to population decline. And as you can see across Africa, trends in elephant poaching peaked around 2011-12 and have been in decline since then. Although I believe in Kruger, the picture more recently is a bit different. So looking at the data for elephant population size, as well as the intensity of legal killing, this is how it varies across the continent. So you've got your Central African sites, which have very high poaching rates. On average, savanna elephants have suffered higher poaching rates than forest elephants have suffered higher poaching rates. Although we do have big hotspots in Tanzania and Mozambique, where there was very high levels of poaching around that peak in 2011, 2012. So I just want to give you a chance to shout out anything. What are some of the factors that might explain why poaching is higher at some of those sites compared to others? If you're not too shy, you could shout something out. Corruption. Okay. Anyone else? Drought? Did I hear right? Okay. Drought? COVID? Poverty. Okay, yeah. Human-wildlife conflict. Abundance. More elephants present, more poaching perhaps. Size of the tusks. Anything else? Law enforcement, number of rangers, that kind of thing. I always do this with this presentation because embarrassingly some factors come up that we didn't consider. But we took a 4-stage approach. And broadly speaking, I buy into this completely from a statistical point of view. Don't just start crunching the numbers and looking for relationships. Generate hypotheses before you've even seen the data. And ideally, those hypotheses should have A, logic to them, and B, evidence supporting them, unless you're exploring a field that's completely new. And then we clarified those hypotheses and we wrote them down very specifically. Then we identified data sets that could help us address those hypotheses, because there's a gap there, isn't there? The hypotheses pertain to certain variables and constructs that we do not have perfect data to represent. Do we have perfect data on poverty? What does poverty mean? How do we measure poverty? So we need to identify data sets, and often we find that we just don't have the data to robustly answer these hypotheses. And the temptation is to use the data anyway, but then your conclusions are compromised. So what we did was we actually ranked the data by ranked the hypotheses by their strength and logic, but also ranked the quality of the data available of them. And we decided to only run the model on those data that had good data, variables that had good data and strong hypotheses. And it's probably why a lot of our variables came out as significant when we eventually ran the stats. So if we look at the variables we selected, this is just some of them. A lot of you have mentioned some of the variables on there, so thank you. And that's just a bit more detail about the hypothesis behind them, the scale at which those variables were measured. You've got variables at a global scale, their impact being Africa-wide, such as the ivory price, and you've got variables at the site scale, for example, the law enforcement capacity at that site. Now, I was amazed by this data set. If you guys are interested in human well-being, the Global Data Lab has collated data from the demographic and health surveys by, I think it's the US government, and UNICEF surveys across the world, and they've standardized responses to those survey questions to develop an internationally comparable wealth index, which has to do with asset ownership and access to basic resources. And they've actually got it at the sub-national level across Africa. So what we did was we extracted the mean household wealth and household health. There was also household health data, and from which we could construct a sub-national human development index. But recommend Googling Global Data Lab. Then this data set was interesting, the armed conflict data set out of Uppsala. Unfortunately, it tells us a sorry picture. Each of those dots represents an armed conflict in which at least one death was involved. And we were able to extract those armed conflicts that occurred within a certain radius of the sites. The green, dark green polygons are the elephant protected areas. So the orange dots represent the ones that are within a certain range of the sites, and we tested sensitivity to that. I won't go into the detail of the stats, except to say, for ecologists, if you haven't heard of regularization as a form of model selection, it's super powerful. It's one line of code often. It's called shrinkage. It works by shrinking the Bayesian prior for covariate effects, such that those that are not strongly supported by the data are shrunk, and those that are increased. And that's in a form, it's analogous to AIC, but it's a lot easier to run. And I think has a stronger conceptual basis. I hope Kenneth Burnham is not in the audience. If we look at the results, these are some of the relationships we looked at. So these are conditional effects plots. They are ones that the partial effect of each variable having accounted for the influence of the other ones. And so we can see the Pike index. So y-axis represents poaching. Poaching across these 64 sites and 20 years, poaching generally declines as household wealth increases, as well as household health. Again, law enforcement capacity is a relationship strongly seen there as well, and national governance quality. So, as was said earlier, corruption is another word to use there. Higher quality of governance, lower poaching. That's across all sites, all mic sites in Africa. And then a simple positive correlation. We're careful to just call it a correlation between poaching and ivory price. This was based on an amazing data set compiled by Traffic of thousands of records of ivory prices. Previously, analyses similar to mine were using mammoth ivory, and this analysis was able to access elephant ivory price data directly. This slide summarizes the results in one figure. Anything to the left of the dotted line represents a negative relationship with poaching, so higher values of governance, lower poaching, higher values of household wealth, lower poaching. And as you can see, the armed conflict one was a little bit tantalizing. It was right on the border, but we conservatively looked at all sorts of different forms of that variable, and we thought that there's just too much uncertainty to claim anything conclusive regarding that. So these are our conclusions. We frame them as support for hypotheses. That's the advantage of stating your hypotheses before. You examine the strength of evidence in support of the predictions of those hypotheses. And so this is what we found. The socio-economic relationship, it's very complex. You'll see in a moment one of the news articles oversimplified that relationship. What is it about more poaching in areas that are relatively socio-economically deprived that causes that relationship? It could be easier for syndicates to take advantage of people in those kind of circumstances. I don't think it means that someone wakes up, thinks they don't have enough money, so they go and kill an elephant. So lots of caveats. The poaching metric has its biases. That's why we did include drought, because drought affects natural mortality levels and therefore affects the Pike index. But we tried to account for that with rainfall anomaly. So these mechanisms are not clear, and we need deeper site-based studies to try and unpack the mechanisms. This study is just suggestive. So if you want to read the paper, you can find it there, Drivers and Facilitators of Elephant Poaching. And that's the title I'm embarrassed about, The Economist. And I spoke to the editor and asked if he could change it, but he said, no, he stands by it. Poor, badly governed people are what causes poaching, according to The Economist. And I think that was just a gross oversimplification of our results. The National Geographic reporter, I had a few more interviews with her, and those were a lot more fruitful, but yeah, I'm sure, as many of you know, greed, in fact, is a driver of poaching. A lot of people who are actually relatively well off continue to poach because it's a profitable business. So it's not just poor, needy people. Anyway, onto the project I'm more excited about. That's the project that was involving partners here in the greater Kruger landscape, evaluating interventions used to try and reduce rhino poaching. So we all know this landscape. Some might be less familiar with the private reserves, and I really want to acknowledge the private reserve managers. Stephen, I guess, was here representing the manager world, but there was a number of other managers on each of these reserves that participated. I did send the link to some of them for today, and I know at least one of them is watching, so hello Edwin from Timbavati. Phenomenal learning experience to sit with managers, talk through the data, run by them the way I was thinking of measuring each of the interventions, talking through what the success measure was. Was it reduced incursions? Was it reduced number of rhino poached? Was it reduced poaching rate? And different reasons for using different metrics. But as a massive shout out to GKEP, they raised the funding for this project. And Sharon herded us all, Sharon from the earlier slide. So yeah, just to emphasize, it was manager-led research. The questions were formulated by managers because it was a question that they really wanted answered. And I've certainly seen how, I think the paper that I've written on this with the help of the managers and other authors is the paper I'm most proud of. And I think the highest impact paper I've ever written, and it's mainly because it was initiated by managers addressing. And I couldn't get away with simple answers. Stephen in particular gave us massive headaches because we were about to release the public report, and Stephen said, no, there's a little bit of oversimplification here, and he was able to justify there's reasons for saying that. I had to come up to Kruger again. We had a day-long workshop. We thrashed everything out, and we were able to get at a much more nuanced story, I think. And that was thanks to not having the convenience of just sitting alone doing the stuff without talking through the results before publishing them with the people who were here locally. Yeah, so I'm just going to shoot through this. There were lots of interventions. Some more novel than others, more interesting, polygraph testing. The organization I was working with, I'm doing another consultancy with them, and while I was there with them, the staff of that organization were being polygraph tested. It's a mechanism that's used to identify people who are internally involved. It's had mixed success. I was hoping Alistair would speak today, but he's been doing some phenomenal work. And I think there's been lots of lessons learned, but that won't be the focus of today. Yeah, advanced camera technology, pan, tilt, zoom cameras, thermal cameras, normal mobile camera traps like those used for wildlife detection dogs. And this is what we were trying to relate those interventions to, is the variation in poaching across these reserves. There's 10 reserves there because Karangani has a I don't think has a well-established rhino population. So whilst part of the study for other metrics didn't have poaching data. So there's the 10 reserves. You can probably all guess which reserve is Kruger, just by the sheer number. But yeah, so we were trying to relate that variation in poaching to the variation in the intensity of interventions. And for this, it was critical to combine stats with manager insights, which I've spoken about already. And these are our hypotheses that we developed or sat down with managers and elucidated the way that each interventions work. You've got those that seek to prevent poaching before it happens. Those focus on detecting poachers as they enter the reserve, sometimes on the fence itself with fence alarms. and then you've got interventions that are involved in reacting to a detected incursions. And each of those have a different pathway by which they lead ostensibly to reduced poaching. So the biggest time effort on the project was quantifying these indices, and we went through various iterations, some more simple, some more complex, but we settled on these 11, the more simple ones, ranges per 100 square kilometers, the proportion of the rhinos present that were dehorned, the number of dogs per 100 square kilometers, and various other indices. And basically we were trying to do this. Is that variation in poaching in any way related to the variation in intensity? We standardized the intervention scores on a relative scale from 0 to 1. We wanted to see if there was a relationship between the intensity of interventions and the poaching rates. So the nice thing here is I'm hesitant to use the language of counterfactual, but we had data before and after interventions, and we had data at sites that did the intervention and sites that didn't. There was large variation in the application of interventions. And we used, obviously it's more complicated than that picture suggests. There's all sorts of other factors that may explain variation in poaching rates that we didn't account for, such as COVID, the arrest of a high-level syndicate, and so forth. This model details another quick plug from a statistician about a really user-friendly package in R called BRMS. It's Bayesian regression modeling. It basically, if you've used LME4, like for your GLMs or GLMER or your mixed models, this is the same syntax, but it fits Bayesian models, and it allows you to specify your priors very simply, and it allows you to specify your regularization technique or your model selection technique in just one line. So very user-friendly, and there's good literature on the package itself, but I found it's very easy to use. Some of you will know the bugs language, and Stan, other languages used to fit Bayesian models can be quite tricky to use. I won't go into that. So $76 million was spent over the 5-year period, about just over R1 billion on various different interventions. Note that the security staff intervention, obviously those staff are involved in activities not related to rhino poaching, but during the study period a large portion of their time would have been directed at trying to stop rhino poaching. And on average, if you look at all the data together, it was about $3,000 US per rhino per year spent on these various measures. So here's the results. We looked at all these interventions, and the only one that had a significant statistical association with the poaching rate was dehorning. It's important to note that this does not mean that the other interventions were ineffective. Unfortunately, in some cases, the variability in the data was not wide enough to give us enough statistical power to say anything conclusive. So I'd rather conclude from this that we'd failed to find significant evidence for an association between the other interventions and poaching. And many of these interventions, if measured in a different way, such as the number of arrests that they led to, were in fact highly successful. If you look at this in a different way, the conditional effect plot, again, you can see how the rate of poaching changes on average with more rhino dehorned compared to something like greater investment in camera technology. But I just want to acknowledge that those cameras, which are equipped with AI, also led to many arrests, and many arrests, contacts with poachers. In the case of the dogs, they led to over 700 arrests. I know we had the talk earlier about arrests are only the first step, but it's certainly the thing that's in the control of the managers and rangers. So these can be considered highly successful in terms of achieving their specific function. And though some of you know about the WAS system here as well, detecting poachers by radar, and often that was before the poaching event occurred. So these kind of interventions are serving their purpose very well. But it was only dehorning that we saw had a consistent effect wherever it was applied, leading to large reductions in poaching. That last slide is Kruger, but at that point it had only done 25% dehorning by the end of 2021. It's now done a lot more, and the poaching rates in Kruger have declined a lot in the last 2 years. Just rushing along. So, measuring these interventions by reduced poaching is a high bar. Many of these interventions can be gotten around with internal information, and a lack of variation in the data may have explained our null effects rather than an intervention being ineffective. But if the data do suggest that these interventions do not significantly reduce poaching, why might that be the case? Dehorning is proactive. That's one way you might distinguish it from the other interventions. These interventions obviously are only effective if you have good follow-up capability. So how are those detections translated into good follow-up? Obviously, you can have a ton of detections, but if they're not followed up, that intervention will not be associated with reduced poaching. Equally, and I think this speaks to Ashley Dawes' point, there's a lot of repeat offenders in this system. A lot of people get out on bail, and if the sentences in the courts are not swift, fair, and certain, the deterrent effect of all these interventions that are focused on arresting is really compromised, not because they're not doing their job well, but because the courts are not effective. So, to dehorn or not dehorn, there's a whole other discussion here. I'd be happy to talk about this afterwards. There's people in this room who've looked at the effects of dehorning on, like Vanessa, on rhino home ranges, showing that in some cases they reduce the home range size. There's evidence to suggest that the dehorning in this landscape has simply pushed poaching elsewhere. But sneakily, I've put in data up to the end of 2023 here now. 3 more reserves have implemented dehorning, and Kruger has dehorned a larger proportion of their rhinos now, and we just keep seeing the same thing. Very consistent and strong effects of dehorning in terms of reducing poaching rates across a large number of reserves in this landscape. So we can just let the data speak there. There are caveats, of course. There's evidence, dehorned rhino are still poached. There's evidence of that. Certain syndicate groups seem to be more willing to poach dehorned rhino than others. But I just want to focus on this broader conclusion that detecting and arresting poachers is critical. I was chatting with Stephen about this, and he said, imagine we did dehorning but nothing else. You would have no risk of poaching, so the reward might be smaller, but we've seen that poachers are very willing to poach. So we would have had probably a high level of poaching if those other interventions weren't in place alongside dehorning. And I think I've made those points already. And all of these are taken advantage of by the criminal syndicates. They know the system. They infiltrate the system. They work around things, and they take advantage of things like socioeconomic inequality. Thanks very much. You can get the full report with that link here. Sorry, I should have left more time for questions.
Thanks, Tim. But yes, the organizer here has got some leeway, and we have got a little bit of time, which we're going to bite into some of the rangers discussion, the little workshop that we're going to have shortly. So I'm going to allow for a couple of questions because I do think it is a very good illustration of how science and management can interface. Andrew.
Thanks, Tim. That was really interesting. I had a question about dehorning. What do you think is going to happen when more and more rhinos are dehorned? So are they targeting horned rhino because they're available? If all the rhinos were dehorned, would dehorned rhinos be targeted?
The short answer is yes, and there's evidence of that in this landscape even in the last year. I would say we're still looking into it. We're doing a deep dive into the more recent data, but a large portion of the rhinos now in this landscape, as far as I'm aware, there's just one reserve that hasn't dehorned rhino, are dehorned. And what we're seeing is the proportion of dehorned rhino that are poached is increasing slightly. So I think there's the beginnings of evidence that if you dehorn all the rhinos, it won't completely stop poaching. Poaching will continue. My contention is that it won't. I don't think it will continue at the same rate it did before. The reward has been reduced sufficiently enough. And it depends on the syndicate involved, because syndicates are mobile. They in South Africa, they do cash and transit heists as well as rhino poaching. So I feel that if you're reducing the reward to that level, other criminal activity may be more lucrative. But it certainly won't completely stop poaching. But I do think it's been very effective and maybe buys time for the longer term solutions.
Thanks, Tim. We've got one more question from Paul there.
You mentioned that you haven't corrected for COVID. Is that something that you would be able to do? Because COVID, there was a global decline in criminal activity with all the ports being closed. So it'd be very interesting if that was possible.
That's a good question. We had to think carefully about this because there was evidence that COVID in this landscape did reduce poaching because there was a lot less mobility on the roads. There were a lot more roadblocks stopping people who shouldn't be driving around during COVID and so forth. And I think Kruger did see a dip in poaching. The way we could have just included a variable before and after COVID, but I think it would have ascribed too much of the variation in that period to that variable. So what we ended up using is a random effect a temporal random effect of quarter. So what that temporal random effect allowed us to do is account for unmeasured variation by the random effect for the quarters within 2020-2019 would have demonstrated a slightly lower poaching level in those years unexplained by the other variables. And any covariate effects would need to be demonstrated over and above that dip in poaching that was attributed to the random effect. I don't know if that makes sense. It's not an ideal solution, but we did try and account for that because it was problematic because a lot of these interventions were kind of implemented when COVID was implemented, and so it really messed things around a bit. But we tried to discuss those limitations in the paper, and it's currently under review, so we'll see what happens. Thank you.
Thank you, Tim, and thank you very much. Let's give him a round of applause, guys. I think this was an interesting illustration of how we utilize knowledge that we've gained. And none of these things, as Tim has highlighted, collated information to test something. And I think often we are in this space when you're in a management space. I think this is where things like adaptive management and all these other sort of things are really important. And we've been in that space for quite a long time. You may remember at one time in past history, there was a colleague, Kevin Rogers, here. And some delegates, which are still in this room, were counting how many times Kevin Rogers' name was called in a conference. Because Kevin was a key instigator of actually having scientists and managers interact through the adaptive management framing that we are talking about. So we're going to have a session now of about an hour and a half, shorter than an hour and a half. This is not going to be streamed or anything because we want to have a little bit of a free-flowing discussion. It's going to be difficult for anybody online or whoever else to take place. But we want to illustrate a bit of the knowledge that sits around and the experiences we have. You would have seen a number of our colleagues walking around here, our rangers. Let's welcome them. Give them a hand of applause for coming to join us. But, they're a rough crowd. You've got to control them a bit. And this is what Kathy's job is.